Okay, everyone, we're going to look at the last section of this chapter on sequences and series and patterns and whatnot, section 9.5, geometric series. Geometric meaning that we are multiplying each time, and series meaning that we're going to add those numbers up to find a sum. First thing, we have our 9.3 review. And that was that a sub n is equal to a sub 1 r to the n minus 1. That was the formula that we used to do sequences and define particular terms or find whatever missing part we wanted to. So that's our review from section 9.3. Okay, the formula for geometric series, I'm just going to give it to you. We're not going to try and make it. So let me just give it to you. The sum is equal to a1 times 1 minus r to the nth power over 1 minus r. Okay, and that looks like a bit there, but trust me, it's actually easier. That formula is much easier to use than actually trying to write out all the numbers and then add them up. So trust me there. We also have a special case. We have something special that can happen. This value of n, it can be infinity. So if n is infinity, which I can't really say, infinity isn't a number, but just play along. If n is infinite, well, a couple things can happen. Whoops. If the ratio is less than 1, it converges to, and we'll have a formula here. The sum is equal to a sub 1 over 1 minus r. And you notice we don't have an n in this formula because n is infinite. Number 2, if the ratio is greater than 1, greater than or equal to, it diverges. Meaning that all those numbers, if you add up an infinite number of numbers, it just gets infinitely large. It doesn't add up to any number in particular. Okay, I need to note something here. I need to note that r is really the absolute value, because r could be a negative number as well. So let me sneak on some absolute values on r, and then this part will be complete. I want to look at one example that's really not like any of the other examples we've had. So let's look at this problem. We're going to use summation notation. Oh, well, this is something just different here. N is 1 to infinity, 3 times 1/3 to the n power. Well, when you're in summation notation, r is whatever is under the exponent. What is under the exponent? In this case, r is 1/3. Because the 1/3 is underneath the exponent there. To find a1, plug in 1 for n. Okay, now this could vary slightly. You see here we're starting with 1, n equals 1, so plug in 1. They could have n equals something else 99% of the time that they won't. But whatever number is here, that's your first term. So plug in that number for n. And that will give you a1. In this case, if you put in 1 for n, that's just 1/3. 3 times 1/3 is 3 over 3, which is 1. So in this case, r is 1/3, and the first term is 1. And then we could use this new formula, okay? Because the ratio is less than 1, we can use this formula to find the infinite sum. So the sum is the first term, a1, over 1 minus the ratio. We could multiply by the common denominator of denominators and do this that way, but this is easy. 1 minus 1/3 is 2/3. If you have 1 whole and you take away 1/3, you have 2/3 left. Copy, change, flip. Copy, change, flip, and then we're multiplying by 1, so that will just stay the same. So if you have this infinite series and you add them all up, add up those infinite number of numbers, you'll eventually get 3/2, which is kind of magical, I know. 3 questions.